Hi guys, today's video we'll talk about parallel and perpendicular lines. There's a couple things we need to get to before we get to some actual Common Core questions related to some notes regarding parallel and perpendicular lines. So if we have parallel lines, they have the same slope. You know that parallel lines never cross each other, they never intersect, so they must rise at the same rate as each other. Rise over run is slope. Perpendicular lines have opposite reciprocal slopes. I just abbreviated that as op-recip. Again, that stands for opposite reciprocal. So this would be an example if we had, say, 1/2 as one slope, its opposite reciprocal, you flip it and negate it. So maybe we want to write flip and negate. And of course, perpendicular lines are forming those right angles, so they would intersect each other to create right angles. Sometimes you're asked to determine if lines are parallel, perpendicular, the same line, or intersecting at an angle other than 90. And in order to do this, you first need to get the equations in y equals. Always get your equations in y equals. After that, we get to compare the slopes and the y-intercepts. Remember that the slope in a linear equation is the m, and the y-intercept is the b. So if the slopes and the y-intercepts are exactly the same, that means the lines are the same. The lines are the same line, or the equations are the same line. The next one says if slopes are equal but different y-intercepts, this is when we have parallel lines. The third bullet says if slopes are opposite reciprocals with different y-intercepts, then the lines are perpendicular. And the last one says if slopes are not related, then the lines are intersecting at an angle other than 90. So we have an example here where we get to talk about determining whether the lines are parallel, perpendicular, the same, or intersecting. So first, again, we have to get the equations in y equals. So I'm going to jot the first one down off to the side here, and we're going to think about getting y by itself. So first that means that we need to subtract 4x. So now we have negative 3y equals negative 4x plus 9. The next step is to divide by negative 3 on all parts. So our new equation is y equals, I have negative 4 divided by negative 3. The double negative turns to positive, and 4/3 cannot be reduced, so it stays. Attach the x, and then we have 9 divided by negative 3. That becomes a minus 3. Then we have to work with the second equation. Negative 8x plus 6y equals 24. Again, bring the x to the other side first. So now we have 6y equals 8x plus 24. Then we divide by 6 on all parts. So this new equation becomes y equals, I have 8 divided by 6, which can reduce to 4/3, with an x attached. Then we have 24 divided by 6, which gives me 4. So now I first look at the slopes. I see a 4/3 and a 4/3. Then I compare the y-intercept, negative 3, positive 4. So it looks like same slope, different y-intercept, which means that these lines are parallel. And we will say because same slope. Again, we cannot compare the lines, we cannot figure out their relationship until it's in y equals. The next type of problem that we might see on a Common Core test is asking us to write the equation of parallel and perpendicular lines. And so to do that, we have this formula called the point slope formula. Y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is that given point. This is a formula that you have to memorize. It's not provided to you on the reference sheet. It's never given on the exam. You have to memorize it. We're going to follow through with these steps on the next example. The first step says get the equations and y equals. So it says write the equation of a line that is perpendicular. Whenever I see keywords like perpendicular or parallel, always write myself a note. I know that opposite reciprocal slopes give me perpendicular lines. So my note says recip slope. So I want to be perpendicular to 2y minus 6 equals 4x, and I must pass through the point -6, +3. I'm going to label this point as x1, y1, because eventually it will get plugged into our point slope formula as x1 and y1. So again, first step says to get the equation and y equals. To do this, we move everything away from the y, starting with the 6, by adding it to both sides. After that, we divide by 2. So now the equation becomes y equals 2x plus 3. From here, we identify the slope in this equation. That's the 2. But now my new slope, we said, remember, needs to be an opposite reciprocal. So 2 gets flipped upside down to become 1/2, and now also gets negated. Remember, oprecip means flip and negate. So now I have my x1, y1, and I have my new slope. So this is where we start by plugging into y minus y1 equals m times x minus x1. So we have y minus the y1 value of 3 equals our slope, -1/2, times x minus the x1 value, -6. We do need to simplify this. The double negative here turns to positive, so we have y minus 3 equals -1/2 times x plus 6. Then we're going to distribute the -1/2. So still again, y minus 3 equals -1/2 x. And then we have -1/2 times 6. So that's actually a -3. You can test it in your calculator to be sure if you need to. Then we're going to add 3 to both sides to get this back in y equals. So now our final answer is y equals -1/2 x. And then -3 plus 3 is just 0. So we actually don't need that new y-intercept because it's just a 0. Alright, we're going to see some actual examples that have been on the Common Core tests over the past 3 exams that they've put out for us so that we can practice at the same level of rigor. Go ahead and flip over when you're ready. So number one says, which equation represents a line that is perpendicular? Here we go with those keywords. Write yourself a note. Do you want to write same slope or oprecip slope if we're looking for perpendicular? I chose to write oprecip slopes. So again, first step, get it in y equals. I'm going to do this silently on the video while you do it independently in your notes. If you need to check back with me, that's fine, but I'm not going to talk through this. So I found that y is equal to 2x minus 7. Now I'm going to identify the slope as 2, but understand that I still need the opposite reciprocal. So again, 2 over 1 gets flipped upside down to become 1 over 2, and negated to become -1 over 2. So we're looking for an equation that has a slope of -1 over 2, which means that we end up with choice A. You can see that -1 over 2 is attached to the x. The next one says that we want to be parallel to MN and passing through the point 6, 1. Now we can do this using point slope formula, or we can do it using the graph. Either option is fine. I'm going to choose to do this one graphically though, because the graph's already there and it's somewhat easier using the graph. So the first thing that we need to do is find the slope of MN. Slope of MN. And we're going to actually do this by taking a nice point like M and finding another nice point like this one and moving over and downwards, or down and over, since slope is rise over run. So we're going down 3 over, or I'm sorry, down 2 and over 3, right? Let me reiterate that. Down 2 over 3. We just made this nice little triangle, rise over run. So now what we do is we take the point P and we do the same exact slope because it says parallel. Parallel means same slope. So we go down 2 over 3, plot the point. But now if I go backwards, I want to go up 2 to the left 3. Up 2 to the left 3. Keep doing that until we don't have space on our graph. And we connect. So now the question is, what equation matches what we just drew? We know that our slope is negative 2/3, which means we can immediately get rid of C and D. Then we look at the y-intercepts and I see a positive 5 and I see a negative 3. If you look at the blue line that I have on my paper, my y-intercept is up at 1, 2, 3, 4, positive 5, which means that we should be choosing choice A. Number 3, another Common Core question, says that we want the equation of a line that's perpendicular to the line represented by y equals negative 1/2 x minus 5 and passes through 6, negative 4. Again, write yourself a note about perpendicular lines. What do we know about them? We know that they have opposite reciprocal slopes. And if we want to pass through 6, negative 4, go ahead and label this as x1, y1. So again, first step, get it in y equals, but this one's already in y equals. So the second step is to take this slope and identify the new slope. Perpendicular means opposite reciprocal, which means we have to flip and negate. So negative 1/2 gets flipped upside down and negated to become 2 over 1. So that means we can cross off choices A and B. But now we have to decide, is this a plus 14 or a plus 16? And there's no way to know this unless you plug in to y minus y1 equals m times x minus x1. Now you could use your calculator and type these two equations in and see which one passes through 6, negative 4, but that seems like a lot of work when we could just do this algebraically. So we have y minus the y1 value, negative 4, equals our new slope, 2 over 1, times x minus the x1 value, 6. Remember again, double negative turns to positive, so we have y plus 4 equals 2 times x minus 6. Distribute that 2, so we have y plus 4 equals 2x minus 12. And get it back in y equals. So we end up with y equals 2x minus 16. Choice D. Go ahead and flip it once you have it. The next problem we have is asking us to determine if the equations are parallel or perpendicular and to justify our answer. That means show some math and then also use some words. So before we can decide if they are parallel or perpendicular, we must get them in y equals. So I'm going to take the first equation here, and then I'm going to write the second equation over here on the right. And I want you to take a few minutes to get these in y equals on your own. I'm going to let the video run and I'm going to do it for myself as well, but I'm not going to talk through the process. So again, try this on your own. If you get stuck, look at the video as I do it. If you need more time, just pause the video while you continue to work. Otherwise, stick here with me and we're going to figure out if the lines are parallel or perpendicular. Once we have them in y equals, we start by looking at the slopes. So I have one that's -7 and the other one that's 1/7. These are opposite reciprocals, which means that our lines must therefore be perpendicular. And we'll justify this by saying because op-recip slopes. Alright, number 5 is our last problem together before you move on to practice. I do want to make note that questions 4 and 5 have not been on the Common Core test, but there's no reason as to why they wouldn't create a question similar to these, especially number 5. It says that we have the equations y equals 1/2 x minus 7 and ky equals 12 plus 6x. So our first step is to get them in y equals, of course. And you might be a little thrown off by the k, but I want you to treat it just as any other number. So we need to divide by k on all 3 parts. So this equation now becomes y equals 6/k x plus 12/k. Again, k is just a number. So it says in part A, what is the value of k to make the 2 lines parallel? Go ahead and write yourself a note about parallel lines. Parallel lines have same slope. So I'm going to take the slope in the first equation, take the slope in the second equation, and then because they're parallel, which means same slope, I'm going to set them equal. From here, we just simply cross multiply to solve this proportion. So I have k equals 12. That's it. Now the second one, it says that we want the value of k to make the 2 lines perpendicular. Go ahead and write yourself a note about perpendicular lines. So here we know perpendicular lines have opposite reciprocal slopes. So I'm going to take this first slope that was already given in the first equation, and I'm going to make its opposite reciprocal. Once I have that opposite reciprocal, I now set it equal to my other slope. 6/k. I lost track of where I was. So again, first find the opposite reciprocal and then set it equal to the new slope. So then again we cross multiply. So we have 6 equals -2k, and we solve by dividing. So k must be equal to -3. And that's it for today's notes. If you have any questions, feel free to ask the teacher that's near you. Otherwise, you can go back and rewind if you need the help, if you missed anything, or you're ready to move on to your practice. Good luck!